A range is a sequence of numbers you can index, map, and fold, but that never actually stores its elements. It computes each one from its position. That makes a range of a billion integers cost almost nothing. This is SRFI 196. Numeric range from 0 to 10, stepping by 2. Range to list makes it concrete when we actually want to see the elements. 0, 2, 4, 6, 8. But you rarely need the whole thing. A range knows its length instantly. 100 here. And here's the trick. Make a range of a billion integers and ask for element 1, 2, 3, 4, 5, 6, 7, 8, 9. It returns immediately because nothing was ever allocated. The value is computed straight from the index. A length of 100, and out of a billion element range, element number 1, 2, 3, 4, 5, 6, 7, 8, 9, right away. And ranges transform without materializing. Range map over 1 to 5 gives a new range of the squares. We only build a list at the very end when we ask to see it. 1, 4, 9, 16, 25. Mapped over a range that never held its own numbers. Ranges are the array you never allocate. Constant time indexing, lazy maps and folds, a billion elements for free. SRFI 196, in Kaappi. The docs and a browser playground are at kaappilang.org. Write the lambda, run on the metal. See you at the next pour. Thanks for watching. Subscribe for more Kaappi.